There we go.
So the true population portion even, nothing weird over the top.
Oh, dang it. I accidentally opened up the homework quiz.
Oh no.
I'll be just a second, guys. Okay. I'm ready when you guys are.
Okay.
Okay.
In reading, I see that the answer. So then we're looking at the requirement of correcting a confidence interval at n equals 100, p equals 5, cat equals 0.1.
So, is number 4 false?
Um, well, I mean, what, they're both greater, aren't they?
At least if I'm doing this right, the numbers that I'm getting were 10 and then 90.
For the requirement section.
Yeah.
But then again, you do have that longer equation up above that, which is like p hat minus p. Wait, but that's for the ninth. That's for the confidence level. Confidence interval. Would you the requirements for constructing are satisfied, I want to say. Because they're both equal or greater.
So we think question 4 is true then?
I think maybe.
That's what I was leaning.
But I'm not 100% sure. The thing, which this may be bad, but the thing about this question is if it's one or the other, we're going to know for next time.
Right.
Two choices.
That is true.
I found under section 2.4 in like the answer the following questions where it asks if the requirements are met for creating a confidence interval, and it gives an example problem, but I don't get where it's getting one of the decimal point numbers. And I don't know about you guys, but I can't find anywhere else where it talks about how you determine that with numbers, like how you.
If you go down to the very bottom in the summary, it tells you, it shows the two requirements. It has the two equations. But I didn't watch the whole video, but I watched the very beginning of Sister Wilkinson's little video, and I just took a picture of her slide, and I mean, it's the same equation, but that's what I was looking at.
So their decimal is the P with the little TP hat. So,
So, so if those are satisfied, are the requirements for conducting a hypothesis test also satisfied?
I'm not sure. It's good to have the videos that we have in this class, like from Sister Wilkinson, and then also from the textbook. But sometimes I wish they would just give you the file to the PowerPoint so you could go back to it.
Yeah.
yeah. So I think the requirements for conducting a hypothesis test is also true because so for confidence interval you use the P with the hat, and then hypothesis test you just use the regular P.
Mm.
And
Okay.
so if you do both of the different, same basic formula. So if you still get greater than or equal to 10, then it satisfies the requirements.
Okay.
And since P is larger than P hat, we should know that it will end up to be normal or satisfied. Okay.
Yeah.
Wow. 75% of them were found guilty.
Would you do 45 divided by 60?
That's what I
That
did, but I don't know if that'd be the point estimate or like the actual percentage of people who were found guilty.
what did you get? What number did you get?
When I took 45 and divided it by 60, I got 0.75, 75%.
Me too.
Yeah.
So just 0.75 then?
That's what I was trying to figure out if that's how we find it.
I guess so.
It says at the very bottom in the summary that the estimator of P is the P with a hat, and P hat equals X over N, and is used for both confidence intervals and hypothesis testing.
Okay.
So I'm assuming that that is still right then, since it says it's used for both.
Yeah, and we only have 2 values given to us.
Mm-hmm. Yeah. Okay, so then from there, we're supposed to create a 95% confidence interval for the true proportion of first-degree murder trials in this state. There, the verdict is guilty. And then we're supposed to input our answers for the margin of error, lower bound and upper bound. So we have to do the margin of error first.
Yay.
So much fun. So would P be 45?
Would T be what?
Would P is it 45? Because N, the sample size is 60.
Right. I guess that does make sense.
Do we think it's 45 though because it's given us? Well, maybe not. Never mind.
Well, that would be the actual number of people found guilty.
That gets you a negative number because you do 1 minus 45.
Yeah.
You can't do the square root of negative number.
No, you can't.
is the formula with p hat in it? I don't think so.
Yeah. Hold on. I don't know.
So what did you guys get?
Because it gives you a negative number. It won't actually tell me because it's an invalid input.
So I got 0.735 somehow.
0.75.
Yeah, so 0.735.
What did you do?
Yeah.
So I took, what number are you guys using for the P with the thing on top?
The 0.75.
You guys are using 0.75. Okay, yeah, so I just plugged that number in for P in the,
Oh, you plugged
I got,
P with the hat in for P?
well, we're doing, did I read the question wrong? Because we're doing a 95% confidence interval.
Right.
Yeah.
So that should be the lower bound, not the margin of error. That's the lower bound that I got. I skipped margin of error.
Oh.
I just scrolled down too far, I guess. But anyways, I almost got it.
So
But
you plugged P. You replaced P with the hat.
yeah, so when you're calculating your your lower and upper bounds, you should do that, shouldn't you? That's what the formula says, right?
I believe so. What my reading.
Oh, that is true.
Okay, so
Yeah.
now we just need to figure out margin of error.
Because the margin of error formula is P. Maybe it's a typo. Maybe it should be P with the hat. I don't know.
I'm kind of confused too because I know margin of error shouldn't be like a difficult thing, but I'm not sure what to do with it.
Because typically, isn't margin of error the what you use for the upper and lower bound, right?
Yeah.
Yeah.
Then why is it different? Because they use different P's.
Well, if you look in section 2.2, it has like for the formulas, it has all P hats. That it doesn't even
Yeah.
any normal P's. So we already have the 0.75. and that's really the only information that we need. Aside
Yeah, because if you
and stuff.
Yeah, because if you scroll down to section 3 when it talks about margin of error, it uses P.
I see what you're saying.
So I
So
thought
I
it
just
was-
Googled it, and the formula that I'm getting is just z times the square root of p times 1 minus p over n. So that's like the second part of the confidence interval
but it's different P's.
formula or whatever. No, it has a top half.
Oh, it does.
The bill on it. Yeah, so
I say the book has a typo.
yeah. Yeah, so that makes sense because like we said, like margin of error is usually included in the confidence interval. So wouldn't we? Do we think that's right?
Well, it makes sense because if you follow the formula that it gives for margin of error without just the P,
Yeah.
it won't give you an output because you get a negative number. So in the square root, so it says invalid input.
Maybe I'll try this and see what I get.
So there's another thing. If you go down further, and it says if no prior estimate for P is available, then it gives a different formula, but that's for sample size.
Yeah.
Sorry, I thought I was going to say something good, but then I saw sample size.
Yeah, I about read that earlier, and then I was like, oh.
I'm not sure.
I'm down for using the P with the heart. Because in that case, I get for the margin of error 0.056 because you're supposed to round it.
Okay. That's the only way I can see that it makes sense.
I'm just calculating it too, so here's what I get. Don't be so difficult. Okay, what did you get?
Rounded 0.056.
So I got 0.109.
%95 confidence interval is 1.96, right?
Yeah,
Okay.
it's probably my calculation somewhere. Line parentheses. And you did 1.96 times the square root of 0.75 times 1 minus 0.75 divided by 60.
Yes.
I'm gonna bet my calculations are wrong.
You could always try yours too, Emily, and then both submit them and see which one's right.
Oh, maybe.
I'm feeling like I might have missed a parenthesis somewhere. I'm gonna try it one more time. Just
Yeah.
because. Let's do that one. I'm still getting the same thing.
I know what I did wrong. I did wrong.
Okay.
I forgot to. So it was showing me the square root answer, so I needed to press enter to get the actual answer.
Oh, okay. So did you get 1.09 or 0.109?
Yeah, and then rounded you get
Yeah.
110.
Yeah.
Yeah.
Yay. Okay. That had me so nervous. So then to do the lower bound, we so this time when I do the lower bound with that number, I'm getting 0.641.
Okay, give me.
I must have done something wrong.
Probably did something wrong.
Emily, are you dividing by 60 or 45?
I've been dividing by 60.
Okay, that's what I did.
I got the same as Emily.
Mm-mm.
Yeah.
Wait, Emily, what did you get again?
I got 0.641.
What are you getting, Abigail?
I was getting like 2.01 something.
Like,
I'm
I'm
gonna
getting
try it one more time.
really close to Emily. I'm getting 0.6404.
So when you did it, did you use like just the 0.110 minus, or the 0.75 minus the 0.110?
The 0.75 minus the margin of error.
Yeah, when I did the margin of error, I used the original decimal point that it gave us rather than like what we rounded up from.
So
So I used like the 0.1095, whatever it was.
for the Z,
Just for like, because the first like the margin of error is just like the second part of the equation, you know? So
Yeah.
after you calculate that, all you have to do is the 0.75 minus.
Oh.
So I used the original number that it gave us, not the rounded number. That's why I wonder if we're getting something a little bit different.
That might be. I typed in the formula for margin of error again. So,
That's weird because it should be the same number still.
yeah.
Maybe
So
we
the
should
lower-
use yours though and not round up to 1. So yours would just be 0.640?
Yeah.
Okay.
Yeah, that's what I got. 0.6403.
Yeah.
That's weird that it gives a different number.
Yeah.
Well, at least it's not 2.01.
Most of us are pretty close.
I've literally gotten 3 different answers and none of them are 0.640.
What numbers are you using?
I'm using 0.75 and 60 and 1.96.
Are you putting enough parentheses in?
I don't know. I tried. Maybe I'll work on that.
Maybe
You guys can continue on though. I
separately.
want to make sure I know how to do it right.
Yeah.
Have you guys calculated the upper yet?
Yeah, I did.
Wait,
I get 0.59567.
Yeah, that's what
guys,
I get.
that's what I was calculating. I thought that you guys had already decided that the lower was 0.110. Are you?
Wait, no.
So Jake, you really did get 0.85 something.
Yeah, 0.859567.
Yeah, it's the
Okay,
upper.
then I wasn't a total failure.
So 0.110 we decided is the margin of error.
Oh my gosh, I don't know why I'm so late to the party here, but thanks for the clarification.
You're welcome.
Oh gosh.
So do you know what the lower bound is now, Abigail?
Yes, I'm re-putting it in my calculator because I thought I wasn't getting it right, but I did at one point get a 0.85.
Good.
So
Okay.
you guys are good. Okay, 0.8595.
Yeah, that's what I got. So it'd be
Yeah.
Okay. So we just
0.86.
okay, yeah, 0.86. Okay, sorry guys.
Just want to make sure that you're on the same page with us.
So then question 10, if we increase the sample size, we expect the confidence interval to increase as well, right?
I think so, yeah.
No, this is a boy.
Well, if you increase the sample size, wouldn't that decrease?
It'll
Yeah.
decrease the margin of error, but doesn't it increase the confidence interval?
Oh.
What I was thinking.
Well, I can never remember.
Maybe. Because, well, if you decrease the margin of error, what would that give you? We can go with decrease. I don't remember. It was increase or decrease.
We'll find out one way or another.
If it's wrong, then it's the other one. All I know is that it's not staying the same, so.
It doesn't stay the same. Sounds good. So to conduct the hypothesis test for the proof, two requirements must be met. If P equals 1/2, what is the smallest n can be that both requirements can still be met?
I have no clue on this one.
So,
I look at the little formula thing and I don't know.
Well, 20 times 1/2 is 10. But then you go, what? 1 minus 1/2 is also 1/2. So n would be at the smallest, 20, right?
I would think so, because if you do 20,
It's 20?
1 minus
I was gonna guess 11, but that was not.
Yeah, it would be 20 because both test things that you have to do, if you put 20 in for n, you get 10 exactly.
On both.
Yeah.
So 20.
Yep.
The next one,
Oh,
100.
So what are you guys using for n in these equations?
So that's what we're trying to find. So we're given P, so n times
I get it.
treat it as if it's equal to 10.
Okay. Yeah, one moment there. Sorry.
And I think on this next one, the smallest it can be is 100.
Um.
I'm getting like 111. How am I getting 111?
Yeah, I don't know.
Well, so you guys got 0.09 for like the 1 minus p thing, right?
Wait, say that again?
Got 0.09 for the 1 minus p.
Yeah, and then you're trying to figure out what n is.
Yeah.
I just got 100 from the one equation and I plugged it into the other and it came out greater than 10. So I just assumed that it must sit, then that's as long as it'll be. Because if you enter
Yeah,
anything smaller than 100 into the one, it'll be less than 10. So.
yeah. If you do 10 n times p, you get 10 exactly. But then if
Yeah,
you
so
do,
on question 12, I'm getting not 100.
so you have to make sure that it passes both tests.
Oh, okay.
So yeah, if you do the 1 minus 100 times the 1 minus p, you get like 90. But
But
if you
Yeah, so
do,
that's what I got. And then
yeah.
I think like, okay.
So then if you do 100 times p, you get 10 exactly.
You guys are getting that on question 12 though?
yeah.
Yeah, because you have to do both tests to be able to figure out what n is.
So the answer is 10 again? Or 100?
100.
Oh. Okay, because alright. I'm just gonna roll with it. I'll figure it out another day.
So 11 is 20, and then 12 is 100.
Yeah.
Okay.
Okay. I don't know.
What about third dimension?
Oh, where'd you put the other half of the pencil?
So 13 is true, right?
That's what I was thinking.
Okay.
To the best of what I can calculate.
And then whenever I did 38 divided by 80, I got 0.475
Yeah, that's what I got.
for the p hat.
That's what I got
Yeah.
too.
Okay.
Oh, we ever taught how to do the test value the test statistic by hand?
That's what I was wondering. I'm going back to the book, but I don't remember doing that.
Yeah, because it always explains how to do it by SPSS.
Right. Which that's where I feel like they're teaching us backwards. But okay.
Yeah.
Bless you.
And then 16 asks, well, I guess the p-value we can figure out. But
That's what I'm just skipping. I'm skipping the test statistic for right now.
Yeah. Okay.
Okay, what question are you guys on? It's also
15.
16. Oh.
so for 13 you put true.
Yeah.
Yeah.
Okay. And then what did you guys get on 14?
We found it to be 0.475.
75. And what did you guys get on 15?
I
That's
don't
the
know
one.
how to do 15, so you skip to 16.
You skipped. Okay.
So
Unless you can remember how to find the test statistic by hand.
the p-value, I don't know if any of you guys have tried it yet. I'm getting 0.0062, but I don't know if that's right.
I haven't calculated the z-score to be able to put in it yet.
Okay. Whenever I did the z-score, I got negative 2.5, I think is what I got. Let me go back in my.
Okay.
So, yes. Yeah.
So I think I found a formula for calculating the test statistic.
Did you find the information?
I think so. I'm gonna try it and then see.
Okay. That would be great.
It looks like the other one though, but it has p in it. It's just z equals, p at the top hat minus the mole over p times 1 minus the mole over n. The square root
So
of
is
that.
the test statistic the z-score?
Yes, actually. Now that I read further. Yeah.
Okay. So what did you get, Abigail, for the z-score?
Negative 2.5.
Oh, I got negative 2.282.
Oh.
Just negative.
What?
You said you just got negative 2?
No, negative 2.282.
Oh.
So again, we're
Did you
close.
Did you use 0.6 as your P?
Yeah, and then and then 80 as N, and then I put the P hat in.
Let me go back. Wait, why'd you use 80? Oh,
Because that's the N.
okay, wait a minute. So I was doing 0.05 to divide it. I just glanced over the stuff, and for some reason I thought it gave us. Anyway, so I need to divide by 80.
Okay.
Okay,
2.269. I get that now.
It's close. It was still a little off.
And then we just have to find the p-value.
Yeah, did you do P hat minus P, Jacob, for your Z-score?
What?
Did you do P hat minus P?
I don't know what I did, but I got the negative 2.26937.
Because I got negative 2.282 and some odd stuff.
Okay.
So that's why.
Because I did the 0.475 and then the 0.6 for the other. And that's what I look at.
okay, I recalculated, and this time I got negative 2.282.
Yeah,
That's
that's
what
what I got.
Okay.
Okay. Yeah. That is an extra digit. I get
Oh, okay.
7.
So then we just want less than. So we only want one-sided. So then for the p-value, I get 0.0112.
Same with me.
An elephant.
Okay.
What did you get?
0.0112.
Okay.
Not one of them is like another. Go ask water. Go ask.
And we will reject the null hypothesis, right?
Yeah, because it's smaller.
That is a very small one. Which means there must be sufficient evidence that the water quality has decreased.
Yes.
Yeah.
There's sufficient evidence, right?
What, Emily?
There's sufficient evidence, right, to say that it has to.
Yes.
Okay.
Yeah.
Okay.
So if you just jump. Red fish. Blue fish. Oh, these ones are green.
Okay, so I submitted mine. Did you guys, on question 3, did you do P with the little wave on top?
No, I did just regular P.
Okay.
I was trying to decide between the wave and the hat.
So I did the wave for whatever reason, and that one's wrong.
Oh,
So
Okay.
I'm not sure which one is right, but
It's the wave
not
with
the
the
wave.
hat, or it's the wave with the hat, the P with the hat.
No,
Okay,
regular
okay, P with hat.
It's the
It's
regular
the regular P.
P.
It's at the end of 2.1. The regular P is the actual population statistic.
Where is it telling you that?
The end of 2.1, it says the point estimate hat is helpful, but it does not give us direct information on how close it is to the true parameter P
Oh.
with nothing added.
So Jacob, are you thinking it's
okay. So then I'll try that.
Emily? Did
Is
you
that
submit yours?
I haven't submitted mine, but
I'll submit mine. Is that the only one that you got wrong, Abigail?
Okay.
is that the only one you missed, Abby?
I'm going through. Let me.
It's supposed to be decrease.
Yeah, so it's just regular P.
And yeah, Emily, that's the only one I missed. So we did really good on this quiz.
I don't remember where I read that earlier, but I must have read it wrong in the lesson. But you found that under 2.1, right, Jake?
Yeah, it's under 2.1, like the last paragraph.
Right, yeah.
I don't know where I read earlier.
Yeah. And the regular P is the right answer. I submitted mine.
Okay. Alrighty. So, what do you want to do if she doesn't like our second idea?
Good question. I don't think we'll have time to resubmit something to her, but I am home on Saturday until like 3 Mountain Time, I think. I don't know what your guys' schedules are like on Saturday, but we could go back over. I mean, then if we don't, I mean, it doesn't take very long. It's a pretty short little questionnaire, but I don't know if you guys want to sacrifice your Saturdays. I mean, hopefully we won't have anything wrong with it, but if we do, I am available on Saturday.
I am too.
Okay, I'm not available on Saturday probably. But I can just talk to you guys over email or whatever, or just text you guys.
And we could just email too.
I was
Yeah.
gonna say it'll all depend on what's going on. It's my grandparents' 50th anniversary party Saturday, so
Oh, fun.
That's important, Stacey.
Yes. I
So, yeah.
really hope I think since we followed the example that was already on there, I'm hoping that we don't have any issues. So we'll just be in communication, but maybe we could just email back and forth. And I think we're kind of, I don't know, at least I feel like we're somewhat all on the same page. Like, okay, we'll do whatever we need to do. Just tell us what you want us to do.
Yeah.
Yeah.
I mean, she could just tell us. I don't know necessarily why we even decide what our projects are. We could just draw them out, or something and roll with it.
Yeah.
I would be down for that.
I kind of didn't get it if she wanted it to be more complex than we were making it, but
I know, but then
She kind of made it sound
Yeah.
like we're making it too complicated and we need to simplify it down.
and I thought it was super simple, but our experiment is way simple, so hopefully that works.
yeah. Okay, well, we'll just
Okay, guys, hopefully on Tuesday.
Yeah.
okay. See you guys later.
yeah.
Bye.
Bye.